A very good morning to all of you. Welcome to the another sub-lecture of metals and non-metals. Today our subtopic is reactivity series of metals. Let's find out what is the reactivity series of metals. First of all, let me tell you what is reactivity series. It is simply the arrangement of metals in the vertical column in the order of decreasing reactivities. It is also called as activity series of the metals. As you know that some metals are chemically very reactive, whereas the others they are less reactive, or you can say they are unreactive. Take the example of potassium and sodium. Look at your left side of the figure. They react very rapidly with the cold water, so they are very reactive metals. Since zinc and iron they react only with the steam, so they are considered to be as the less reactive elements or metals. On the other hand, copper and silver they do not react even with the steam, so they are quite unreactive metals. Now, why some metals are more reactive and the others are less reactive? What is the difference? Let's find out. When metals react, they lose electrons to form the positive ions. Now, if the metal atom can lose electrons easily to form the positive ion, it will react rapidly with the other substances and hence it will be more reactive metal. But on the other hand, if a metal atom loses electron less readily to form the positive ion, it will react slowly with other substances. Such a metal will be less reactive. Take again the example of the sodium. Here, the sodium atom loses electron readily to form the sodium ion, due to which the sodium metal is very reactive. But on the other hand, iron atom it loses electron less readily to form the positive ion. So you can say that the iron metal that is less reactive. Now coming to the causes of reactivity. What causes the reactivity of the elements? First of all, look at your screens. All atoms want to have a completely full valence electrons. That means normally they want 8 electrons in their shell. For a moment we will only concentrate on the main group of the elements. Fine. So noble gases are already full as you know, but the elements that are really close desperately want to get their halogens and alkali and tend to be more reactive elements. When metals react with non-metals, they form ionic compounds, means which contain ionic bonds. But when non-metals react with other non-metals, they form covalent compounds, which contains covalent bonds only. Metals, however, they do not react with other metals. Look at this now. What do you see? Octet rule? Let me explain you what is this. If you look at the number of electrons in the outermost shell of the inert gases, you will find that only helium is the only element which has 2 electrons in its outermost shell, and all other inert gases have 8 electrons in the outermost shell of their atoms. Since the atoms of the inert gases are very stable and have 8 electrons in their outermost shell, therefore to have 8 electrons in their outermost shell of an atom, it is considered to be more stable arrangement of electrons. That means to have 8 electrons in the outermost shell of the atom, that is called as octet of electrons. Look at your screens, octet rule. Most of the inert gases they have octet of electrons in their valence shell, but to have 2 electrons in the outermost k shell is called as duplet of electrons. But helium is the only inert gas which is having duplet of electrons in its valence shell, that is 2 only. Thus you can say that the usual number of electrons in the outermost shell of the atoms of noble gases is 8. Only in the case of one noble gas, that is helium, the number of electrons in the outermost shell, that is 2. So you can say that helium is the only inert gas having less number of electrons in its outermost shell. Now coming straight to the formation of sodium chloride. How is sodium chloride formed? As you know that sodium is a metal whereas chlorine is a non-metal. Sodium metal it reacts with chlorine to form the ionic compounds, that is sodium chloride. Let me tell you how. The atomic number of the sodium is 11. Fine. So its electronic configuration will be 2, 8, 1. That means in K shell it will be 2, in L shell it will be 8, and in M shell it will be 1. So sodium atom has only one electron in its outermost shell. So the sodium atom it donates one electron to the chlorine atom and forms sodium ion. Now, coming straight to the chlorine, its atomic number is 17, as you all know. So, its electronic configuration will be 287. So, chlorine atom has 7 electrons in its outermost shell, but it needs one more electron. For what purpose? In order to achieve the stable 8 electron inert gas configuration. But here, the chlorine atom, it takes one electron from where? From the sodium atom and forms a negatively charged chlorine ion. When sodium reacts with chlorine, it transfers its one most electron to the chlorine atom. By losing the one electron, sodium atom forms a chlorine. This sodium atom, yes, it forms a sodium ion, and by gaining the one electron, the chlorine atom forms a chloride ion. Look at this diagram. This is a diagram which has shown the formation of sodium chloride. Thus, you can see that sodium chloride is an ionic compound and contains ionic bond. But it should be noted that in the formation of the ionic bond, the reacting atoms achieved the inert gas electronic configuration by the transfer of electrons.